Well, good day and welcome to our webinar on reducing gymnast exposure to flame retardants. I see that we have people joining fairly rapidly, so let's just give it a couple of minutes to give people a chance to log on, just a couple of minutes, and then we'll get started. Well, hello, we'll get started now. My name is Mark Miles, and I'm from the Toxic Use Reduction Institute. Before we introduce our speaker, let me just fill you in on a few logistical details that you'll want to know. First of all, everyone's microphone will be muted, but we do encourage you to submit questions, which you can do via the chat function. You'll find that near the bottom of the control panel that you should see on the right-hand side of your screen. And with the chat function, you can type in your question or a comment at any time during the presentation, and then what we will do is we'll collect those, and then at the very end of the presentation, we'll have a question and answer period, and we'll present those questions and comments to our presenter for her to comment on and answer. Another thing you should know is that there will be an extensive survey that we will be emailing you right after the webinar concludes. And this is a very important part of the research that you're going to be hearing about. So please, if you will, do take the time and fill that out when you do receive it. So let me introduce our presenter now. Our presenter is Courtney Carrington. Courtney has a PhD in environmental health from the Boston University School of Public Health, where she investigated flame retardant exposure among 3 populations: nursing mothers, office workers, and gymnasts, which you'll hear about today. She is a former competitive gymnast herself and is the founder of the Gymnast Flame Retardant Collaborative. She completed postdoctoral training at the Dartmouth Center for Children's Environmental Health and Disease Prevention Research and is currently a postdoctoral fellow at the Harvard T.H. Chan School of Public Health. That's where her primary research focuses on endocrine disrupting chemicals and the effects on human fertility and reproduction. The work she's describing today was partially funded by the Community Grants Program here at the Toxic Use Reduction Institute. So, Courtney, we will run the poll here. And is Courtney unmuted? If we unmute her. And Courtney, I believe you wanted to start off with our initial poll. Is that right?
Yeah, that'd be great, Mark.
That would be good. Okay, so this will take just a minute, and if you will all see a poll question on your screen in just a moment here. And if you would just, we'll take less than a minute to ask you to select one of the following of the 5 options that you see there. So it looks like we have no more responses coming in. It looks like most of you have answered, about 60% of you have answered other, and the greatest response that we got for the actual delineated choices is as a gym owner or coach, which is good to know. We've got another question for you. Here we go. If you'll answer this question for us as well. Questions, responses coming in here. Okay, looks like everybody's responded that wants to. The biggest choice here is medium, but followed fairly closely behind by high interest, which is great to know. And one more question. How would you rank your concern about gymnast exposure to flame retardants? And again, high, medium, or low? Responses coming in here. And this is pretty decisive. It looks like by far the greatest number of you, over 50%, rate this as a high concern. So with that, we'll turn it over to Courtney, and Courtney will show your screen. If you'll press your show my screen button, and we'll turn it over to you.
Okay, thank you, Mark. So there's two goals of this webinar today. The first is to communicate to you information about flame retardants in gymnastics and solutions that we're currently working on. And the second is to engage you in finding solutions to this issue. And so as Mark noted, you can submit your questions and comments, and these will be used in the question and answer period at the end of the webinar. And the second thing we're going to do is send out a feedback survey by email that you'll receive, and we'd really appreciate it if you could take the time to fill that out. So I'm going to jump right into it, and if at any point you have trouble hearing me, somebody just jump in and let me know. Mark was breaking up a little bit for me. I don't know if anybody else is having that problem. So endocrine disrupting chemicals are the hundreds or more exogenous chemicals or mixtures of chemicals that interfere with any aspect of hormone action. And so this figure is showing a hormone mimic or an endocrine disrupting chemical that it can bind to the hormone receptor on the cell membrane and elicit an identical response in the cell as the one that's caused by the hormone. Another thing a hormone mimic could do is it could bind to that receptor and simply block the binding of a natural hormone. And so this is why it's called an endocrine disruptor, because it can disrupt hormone action in different ways. And the types of hormone action that can be disrupted by endocrine disrupting chemicals include thyroid, estrogen, and androgen action, among others. And there's two characteristics of endocrine disrupting chemicals that sort of set them apart from other environmental chemicals that we study. One is that they, like hormones, they can act at low levels in the body. And the second is that they act in sensitive time windows of development. And so when we do our research, we particularly are thinking about the perinatal period. So that is the period that ranges from preconception through pregnancy and into infancy and early life. With some of the chemicals we're going to talk about today that sort of accumulate in the body, that accumulation occurs over the lifespan. And so when we're thinking about exposures that occur in pregnancy, you know, these include exposures that have been occurring up into and including pregnancy. So these two properties of endocrine disrupting chemicals are part of the reason that haven't been well captured by our regulatory framework. And the other is that endocrine disrupting chemicals, many of them are used in products in our everyday life, like our personal care products. I'm thinking about parabens, phthalates, triclosan, chemicals in our canned food like bisphenol A, flame retardants in our consumer products, which I'm going to talk about a little bit, and food packaging contains PFCs and can contain phthalates and others. So these products really aren't well captured by our regulatory framework, and so this is also a problem with our toxic substances control. So this was an article that was published, a review article that was published in Endocrine Reviews last year, and it was summarizing evidence of endocrine disrupting chemicals and their role in that they can have effects on fertility and reproduction, neurodevelopment, so with exposure in early life and to the fetus can have effects on neurodevelopment later in life. The neuroendocrine systems, obesity and diabetes. Many endocrine disrupting chemicals are considered potential obesogens, again with exposures in early life having later life effects, and as well as hormone-sensitive cancers. So, we've seen an increase in cancers of the breast, the ovary, testicular cancer, and prostate cancer, and so these are cancers we consider hormone-sensitive. So flame retardants are in many products in our homes. Historically, they've been used in upholstered furniture, the plastic casings of electronics, in home insulation and carpet padding, and in some baby products. And more recently, I'm going to talk about this a little bit later, upholstered furniture and baby products. There's been some efforts to try to exempt these products from really needing flame retardants. And these flame retardants can escape these products, then enter the air and dust of our indoor environments and enter our bodies. And one of the primary ways that they enter our bodies is through accidental dust ingestion, so that flame retardants get in our hands and then we accidentally ingest them. One of the main flame retardants that have been studied over several decades are the polybrominated diphenyl ethers, or PBDEs. And these chemicals can last in the body on the order of years. So what that means is that the body has a hard time eliminating these chemicals. And so what happens is if over time they're accumulating in the body. And so what this graph is showing here is that infants can have high exposures, and that's partially due to their exposure and during fetal life, but also through breast milk, because polybrominated diphenyl ethers are something we call bioaccumulative. Like I said, they accumulate in the body and they're sort of mobilized from the fat and are excreted during breast milk, excreted in breast milk, excuse me. And we still think that breast milk is the most important food for babies, and that it's still the most healthy food for babies, but really it would be better that if breast milk didn't contain these types of chemicals. We also see elevated exposures in early life, at ages 1 to 5, and this is partially also due to the long half-life of these chemicals, that they had high exposure levels as infants and it's slowly coming down, but also to do with the dust ingestion that I spoke about previously. Sorry, the bubbles are distracting me, people coming in and out. So over several decades, we've been studying health effects of polybrominated diphenyl ethers, and we now know that they can affect thyroid hormone in humans with reductions in thyroid-stimulating hormone and T4. And thyroid hormone is really important in development development and metabolism. They can also have effects on female fertility. Some studies have found increased time to pregnancy among those with higher levels of PBDEs in their blood, and also higher rates of failed implantation. Exposure during fetal life can have effects on neurodevelopment. The studies showing effects on behavior, cognition, and motor skills during in young children. And there's some studies showing those with higher levels of ADHD or higher exposures to ADHD prenatally, and higher rates of ADHD in those who have higher exposures to PBDEs prenatally. So penta-BDE, which is one of the PBDE mixtures that was used in foam, began to be phased out of use in 2005. And it was replaced with other flame retardants that are now used in foam. And these include tris-1,3-dichloro-2-propyl phosphate, or TDCPP. And this is a flame retardant that was phased out of children's pajamas in the 1980s. It was also known as chlorinated tris. And this was because of concerns that it was potentially mutagenic. And it continued to be used in polyurethane foam, it seems like particularly in the foam of cars, and then was used as a replacement for penta-BDE. Another flame retardant that replaced penta-BDE in foam is Firemaster 550, and this is a mixture of phosphorylated brominated flame retardants. And now we're sort of calling this regrettable substitution because because these also appear to be endocrine disrupting chemicals, and we're starting to find health effects associated with these replacements as well. So as Mark mentioned, I'm a former gymnast, and I was doing my dissertation research at Boston University School of Public Health on human exposure to flame retardants. And we were thinking about, well, what are products that contain polyurethane foam? And so we think about couches and changing pads and nap mats, foam mattresses and pads. Most standard mattresses actually don't contain flame retardants, but if it's a mattress pad that's primarily made out of polyurethane foam, it likely does. Nursing pillows and foam insulation, and as a former gymnast, I knew that gymnastics training facilities really have a large amount of polyurethane foam, particularly in the landing mats and the loose foam pit. And I could remember as a gymnast, landing in the pit and coming out sort of covered in this film of pit dust. And I was concerned that the foam, particularly the foam in pits, might contain flame retardants. So I went out and sampled a gym, actually pit cubes from a few gyms, and I found that yes, in fact, they did. So what we see here is sort of similar to what we see with residential furniture, that pit cubes from Gym 1, Gym 2, and Gym 3, these are sort of older pit cubes, and they all contained the PBDE mixture or the FireMaster mixture. They had a little bit of TDCPP in them and TPP. And that these newer pit cubes that I obtained from a distributor contain the FireMaster mixture and TDCPP. Sorry, actually it was odd that the one older pit cube contained components of the FireMaster mixture. But otherwise, most of the older pit cubes contain PBDE primarily. I also found that Gymnast contained extremely high levels of flame retardant. So I want you just to note that the y-axis for this graph and many of the graphs I'm going to show you is on the log scale. So this difference between Gym 2, which is the sort of reddish bar, and the residences is over 2 orders of magnitude difference. And this was really the highest level. This was dust collected directly from the pit, but we also had some samples from other parts in the gym. But these gym samples had the highest levels of flame retardants we'd ever measured, and I think the lab had to dilute the sample like 3 times in order to get a measurement on it. So I'm a former risk assessor, so the first thing I tried to do was estimate gymnast exposure using these sort of a dust ingestion exposure. So I took the concentration of the flame retardant that I measured in dust from the gym, multiplied it by the amount of dust ingested per day, and divided it by the body weight. And then I actually also applied an absorption factor. I think I assumed that only 70% of the flame retardant was absorbed by the gut. And I got these really, really, really high exposure levels. So this is the light green line is the gymnast exposure comparing to the general population for these different age groups. Again, so you see these are orders of magnitude difference. And I wasn't sure how realistic this was. There's a lot of factors that influence exposure that I wasn't able to account for. So some factors that we would expect would decrease gymnast exposure, or at least these calculations, are that they're not spending all of the time in the gym. So was the dust ingestion number that I was using really that accurate? We know that hand washing behaviors can help decrease exposure. Like I said, you're going to absorb less of the chemical probably than you're exposed to, so was that absorption factor accurate? And gymnasts, you might expect, might have higher metabolism and excretion of these compounds compared to the general population. Some factors that might increase gymnast exposure during practice are that, when you land in the pit, there's a lot of dust that is sort of suspended, and so dust ingestion actually during practice might be higher than sort of in a regular daily life. Exercise is going to increase ventilation rates, so inhalation, total inhalation might be higher during a gymnastics practice, and dermal absorption also might be increased because of increased permeability of the skin due to sweating. Okay, so now I'm going to talk about the study. So I wanted to sort of get a better measure of potential exposure among gymnasts, so I went out to collect some more samples. So I recruited a team of collegiate gymnasts from the eastern United States. This was 11 college-age gymnasts. They all reported having been gymnasts for the past 12 to 19 years, and that they trained an average of 10 to 19 hours per week currently. I was looking at flame retardants that I knew were used in polyurethane foam, and we collected measurements, collected samples of their blood and their urine, and also wiped their hands to get the amount of flame retardant that were on their hands both before and after practice. I also got measured flame retardants in gym air, dust, and foam. And all these measurements were done by our collaborating laboratory at Duke University. So I found that pit cubes had the highest concentration of bromine, which is an indicator of the presence of brominated flame retardants. So here the dot is showing the average level of so, I had more than one measurement per sort of equipment type. So the dot is showing the central tendency value, and then the bar is showing, I think, the min and the max around that value. So you see that the highest concentrations of bromine were found in the pit cubes, with the second highest in the landing mats, the third highest in the sting mats, and the vault runway. And then we had basically non-detects in the vault runway foam, the above ground pit, the springboard, floor foam, and floor carpet. So this isn't to say that we would never find flame retardants in these other pieces of equipment, just that we didn't in this one gym. Also, it could have contained another type of flame retardant that's not brominated, such as TDCPP or the... I found that air concentrations in the homes were much higher, air concentrations in the gyms were much higher than the homes. So here the green, red, and orange bars are showing air measurements in gyms, and then the blue bar showing measurements from residences in the Boston area. So again, you see these levels of PBDE are orders of magnitude higher than the Boston area residences. We also see, whereas they're not as elevated for BDE 209, which is a flame retardant that's used primarily in electronics. And we see a difference depending on where we took our air measurement in the gym. If it was near the pit, tended to be higher than if it was away from the pit near the gym entrance. And the flame retardants identified in pit foam were extremely high in gym dust. So remember, we measured penta-BDE, TBB, and TBBPH, which are the FireMaster mixture in the pit foam. And again, we see that these concentrations were orders of magnitude higher in the dust compared to Boston area residences. So gym 2 was the data I showed you before, and now I'm adding on gym 1. We also found significantly higher concentrations of flame retardants on the gymnast's hands after practice compared to before. And again, that was for BD47 as part of the penta-BDE mixture, and TBB and TBBPH are part of the FireMaster mixture. And looking at blood, we found higher levels in the gymnast blood compared to the general population. So these sort of symbols in this graph here, or this figure, are showing the geometric mean concentration. In gymnast is the white circle, and then the line is showing the 95% confidence interval around that geometric mean. So it's basically used in statistical comparison. So we see that the levels in the gymnast blood were similar to a population of foam recyclers and carpet installers, and 4 to 6 times higher than the general population. So I compared to a number of different sort of general populations because we didn't really have an ideal comparison group, which really would have been other students at the college. So this last slide was for BDE 153, which has a half-life of about 6 years. So that means it takes about 6 years for half of the amount of this chemical to be eliminated from the blood, assuming no additional exposure. BDE 47 is also another congener of the penta-BDE mixture, and its half-life is on the order of 2 to 3 years. And so we see that the levels in the gymnast blood were not as elevated compared to the general population as it was for BDE 153. And we think that this is an indication of higher past exposure. Gymnasts would have been using the pit more as younger gymnasts when they were spending more time learning new skills. So those were just a few gyms, and we were sort of looking to see is use of flame retardants in pit cubes common across the United States. And so we opened up foam sampling through the Duke Superfund program to invite gyms and gymnasts to send in samples of pit cubes. And what we found was that about 89% of them did contain flame retardants. And we saw a similar trend as we see for residential furniture, that pit cubes from that were purchased prior to 2005, the PBDE phase out, tended to contain PBDE and some of these other flame retardants as well at times. And that those collected after 2005 tended not to contain PBDE, but contained these replacements, Firemaster and TDCPP and some others. So in conclusion, we found that evidence that gymnasts can be highly exposed to mixtures of flame retardants used in foam training equipment. And we've tried to make some suggestions that might help gyms and gymnasts reduce exposure to flame retardants. So the first recommendation we've made is to implement a hand washing policy. So some of the other research we've done has shown that people who wash their hands more frequently have lower levels of flame retardants in their blood. So one simple thing to do that might help is to implement a hand washing policy. So you could post a sign like the one shown here and just get your gymnasts in the habit of washing their hands as they leave the gym. Another step you could take is to take precautions when cleaning the pit. So this is something that I've done, and I just remember as a gymnast how much dust was suspended in a pit cleaning activity. So one suggestion we've made is to wear an N95 rated dust mask, and I'd recommend the type with a ventilation valve because that sort of just helps you be able to breathe. It can be hard work, and you might just want to rip that dust mask off. So a ventilation valve might help make that more comfortable. It might also be helpful to wear some protective clothing and, of course, wash your hands afterwards. So these are kind of common sense suggestions that we haven't had the chance to test yet. Another suggestion that's been used with other populations with regards to reducing exposure to flame retardants is to vacuum regularly. I have a vacuum with a canister personally, and I always wish it was a bag because of when I empty the canister, there's sort of this big puff of dust that comes out. To use a HEPA filter and to change and clean that HEPA filter regularly. I don't know if that's practical advice for a gym if that would get clogged too much, but in sort of residential settings, that's something that can help potentially. And then again, wash your hands after handling your vacuum cleaner bag. And another thing that might help is having a good ventilation system and changing the filter regularly. And another thing we thought about that might help is a chalk eater. I'm sort of interested in whether or not chalk will absorb flame retardants, and if so, that might be a sort of useful in gyms for reducing flame retardants in the air. Gyms certainly tend to have lots of chalk. Another suggestion is other suggestions that can be useful might be to cover your pit cubes or to use flame retardant free foam instead of pit cubes that contain flame retardants. So this is something that we're looking into. And just to note that if you're putting a cover over a foam that contains flame retardants, I have heard that that can really help reduce the level of dust in the gym and in the pit. And so it seems like this might be helpful since we know that dust ingestion is an important way that we're exposed to flame retardants. But we do know that flame retardants can escape furniture, and furniture has a cover, so we wouldn't expect it to completely eliminate exposure. What we've done to try to help communicate with the gymnastics community is I founded the Gymnast Flame Retardant Collaborative, and so on the website, which I encourage you to visit if you haven't already, we have information that I've shown you today. We also have the suggestions that I went through, some information on health effects of flame retardants, and then we have a way to stay updated. And so you can sort of click this link if you haven't already, and you can get updates by email or social media. And so the Gymnast Flame Retardant Collaborative was founded by myself, my thesis advisor, Tom Webster, and Heather Stapleton from Duke University, who's been so helpful with analyzing all these samples for flame retardants and is really an expert in the field. And the collaborative now has over 100 members, and these include gym owners, coaches, gymnasts, gymnast parents, equipment suppliers, and scientists. And we've sort of I've talked to lots of you on the phone mostly, and I was able to get some feedback from you all about what are the barriers to being able to replace a foam pit with flame retardant-free foam? And the feedback I've gotten is that the fire marshal basically requires a lot of gyms to purchase flame retardant equipment or pit cubes that contain flame retardants and other equipment that contains flame retardants. And that the California Technical Bulletin 117 is often the standard, the fire standard that's cited. And this is actually a residential furniture standard that has sort of been widely applied, but it's sort of unclear whether it's a useful standard to use for foam pits. It sounds like the concerns regarding fire safety are legitimate, that polyurethane foam is highly flammable, especially when it's, well, I don't know if this, I was going to say especially because when it's uncovered, but I think it sort of depends on what the cover is. And that non-compliance to what the fire marshal is asking for could result in a gym being shut down. So, sort of this concern about fire safety, I think, is really one to take pretty seriously, and certainly gyms don't want to be shut down, so I understand why it can be hard to move away from flame retardants and foam. So we sort of set out to try to help gyms with this problem, and designed wanted to design a flammability study and come up with some information that would be useful for gyms and fire marshals in this problem. And we wanted to take some of our lessons from the upholstered furniture industry. So this is something like that I mentioned that's been worked on for quite a while now, trying to help the upholstered furniture industry move away from flame retardants. And what they found is that flame retardants and foam are not as effective as they have been advertised, and that fire safety can be maintained without the use of flame retardants. And so there's kind of been a lot of news coverage on this, and there's an HBO documentary called Toxic Hot Seat that you might want to watch. It's pretty interesting. There's also the Chicago Turbine series, Playing with Fire. So both of these have more information about this controversy and this issue. But basically what they've done is been able to improve fire safety without the use of flame retardants. So on the left here we're seeing on the top panels are both non-flame retardant foam, and on the left and on the bottom panels is flame retardant foam. And on the left, there's no fire barrier, and on the right, they're using a fire barrier. And so what you can see is that the use of a fire barrier is much more effective than whether or not there's flame retardants in the foam. And in fact, that whether or not flame retardants were in the foam, the couch was still, going up in flames. And so they revised the fire standards for upholstered furniture in a way that negates the need for flame retardants. So the historic TB117 used an open flame test just to the foam, and the new TB117 uses a cigarette smolder test using a composite of the fabric, the barrier material, and the foam. So we set out to do some studies to see whether we could maintain or improve fire safety without the use of harmful flame retardants. And this formed a collaboration between myself, a fire engineer at Worcester Polytech Institute, and a researcher at the Silent Spring Institute. And we obtained funding from the Toxic Use Reduction Institute at UMass Lowell for this study. And the first thing we did is a literature, I did a newspaper search using Factiva and the NFPA database to look at the number of fires and the causes of fires in gymnastics training facilities in the U.S. From 1996 to 2012. And identified 3 that were arson, 2 from welding sparks, 1 from a frayed electrical wire, and 1 from a cigarette. And then quite a few of these were unknown. And if you know of one that's not on here, please let me know, because I want this to be as comprehensive as possible. From this, we identified 2 test sources consistent with the causes in gyms. So the open flame test would be sort of replicating sources of arson, welding sparks, and frayed electrical wire, and the cigarette would be replicating an accidental cigarette fire. So we're going to use these tests on 3 systems. One is the sort of typical flame retardant uncovered foam. The second is flame retardant free uncovered foam, and the third is flame retardant free foam covered with a polyester cover. And we're asking the question, what is the added fire safety? We're also using two different configurations. The first is a single pit cube, which is somewhat similar to what's used in TB117 method. We're not using the TB117 method because it has to be sort of a couch configuration, and obviously some pit cubes aren't couches. So we're also using this pile of pit cubes for propagation testing. And that's what's shown here on the right. Sorry, I can see your comments and they're distracting. Mark, is there a way to turn that off? Because I keep reading them when they come out. Or at least turn it off so I can't see it.
Yes, Courtney, if you hit, there's a little, on your control panel, a little white arrow on an orangey red background, and if you just hit that, it will collapse your dashboard screen.
No, I've done that, but they still pop out, and it's popping out when people come and leave, and it keeps, it's distracting me, but I'll just try to ignore it a little bit better.
Yeah, I'm afraid that's all we can do, I guess.
Yep, that's all right. Okay, so these are just results from our preliminary testing using the open flame test. And so far what we're finding is there's very little difference between the systems. So on the left panel we're seeing at 20 seconds and at 45 seconds the pit cube with no cover but does contain flame retardants. In the middle is the flame retardant free pit cube with no cover, and on the right is the flame retardant free pit cube with a polyester cover. And we can see at 20 seconds and at 45 seconds it looks like actually the one that's burning the slowest is the flame retardant free. And of course this is just based on one test, and we have a lot more to do, but just sort of so far indicating there's not a whole lot of difference between the systems. So the next steps, so next we're going to do a full-scale test, and we're going to use both the open flame test and the cigarette smolder test. So it might be that we'll get different performance using the cigarette smolder test, or it might be different when we use the propagation testing. We're also going to review other fire safety interventions, such as detection, alarm, and suppression systems, in terms of ways to improve fire safety in gyms. From our findings, we plan to create a fact sheet aimed at gyms and fire marshals to help them communicate on this issue. And we also are planning to conduct an intervention study. So the fact sheet would have information on flame retardants in health, results of our flammability study, and suggestions for maintaining, improving fire safety in gyms. So the intervention study we're thinking about doing would measure the effectiveness at reducing flame retardant exposure by implementing a hand washing policy, putting covers on flame retardant pit cubes, and replacing a foam pit with flame retardant free pit cubes. And I know that there's work been done in a Seattle gym where they've already done the replacing the foam pit with flame retardant free pit cubes, and they are, I think, looking at this question as well, but maybe in a little bit of a different way. I think there's also a study on coaches that should be coming out soon as well. And also a study that has found, has compared levels in gyms to levels in homes. I think 3 gyms and 3 homes, and also found an elevation in flame retardants in gym dust. And so one way that we plan to sort of communicate these findings is via our listserv. So if you got an email about this webinar, then that means you're on the Gymnast Flame Retardant Collaborative listserv, and so you don't need to worry about this. You can also like us on Facebook. We have a Facebook page now that I'm trying to promote and sort of help people learn about this issue. I think we're also going to post this webinar on the website and probably the feedback survey as well, so that people can get information on the website, another way to stay updated. So as Mark mentioned at the beginning, one of the important things of this webinar is that we want this knowledge to go both ways. So I just gave you some information, and we'd really like to get your feedback on, how you thought this webinar was, how you'd like to receive future communications, whether or not you might want to join a working group or a monthly call on this issue. If you know of a Massachusetts gym that might be interested in participating in the type of intervention study that I described. And then we also have about 20 questions to inform our research. And so you'll receive an email about this probably tomorrow, and I'd really appreciate it if you could click on the email link and take 15 minutes to fill out our survey. So just to summarize, we found that gymnasts can be highly exposed to mixtures of flame retardants used in foam training equipment, that gym fires are not common, but they do tend to be severe. We're currently conducting flammability testing of pit cube systems and plan to develop a fact sheet and intervention study, and we really need your feedback on ways to improve engagement with the gymnastics community. So before we get to our Q&A, I just want to take a minute to acknowledge all the folks that have been involved in the study. Researchers at the Boston University School of Public Health, where I did my dissertation research, particularly my advisor Tom Webster, our collaborating chemists at Duke University, especially Heather Stapleton, and Andreas Sojin at the Centers for Disease Control, who analyzed our blood samples. Fire engineers at the Worcester Polytech Institute, Robin Dodson at the Silent Spring Institute. Funding for sort of my time and training has come from the National Institute of Environmental Health Sciences, and funding from the Toxic Use Reduction Institute at UMass Lowell for the flammability study, and also for help with hosting this webinar and everything. They've been so supportive. Really appreciate it. And last but not least, I really want to thank the Gymnast participants and their coaches, the equipment distributors who have been working with us on trying to find a good solution for gyms with pit cubes, and members of the Gymnast flame retardant community, and you all for your attention. And I think now we have one last polling question right before we get to the Q&A. Oh. Mark, do I have to do something?
No, everyone seeing, we had me on mute there. If everyone would once again answer this question on the poll, and the question's responses are coming in. Your concern about gymnast exposure to flame retardants, and it's considerably higher than it was at the beginning of the webinar. About 2/3 of you were saying that it's high, and another third of you that it's medium, and none of you thinking that this is a low concern. So thanks for everyone for doing the polling questions. Now just let's open it up to a general question and answer period if you have some questions for Courtney. I'll start with, please again use your chat function, type in any question that may have occurred to you, or even for that matter a comment, and we'll relay them on to Courtney. We'll start with, since we were most recently talking about flame testing, fire testing, one of the comments that we got has to do with sources of ignition. It appears that open flame ignition is relatively rare compared to other sources of ignition. Is that right, Courtney? Do we have that correct?
Yeah, so it looked like 3 were arson, which I would assume is open flame, and then the others were welding sparks and frayed electrical wire. And the fire engineer that I'm working with thought that the open flame was sort of the closest test scenario that we could get to those without, I don't know, I think there was some reason that we couldn't do that, but if you have any suggestions, I'd love to hear them.
Okay, another question that's just come in here. Looking forward to the fact sheet and asking, are we still hashing out our pit cleaning processes? Oh, I guess it's just a comment, but that does lead me to a question actually. Are you still continuing to research pit cleaning processes, and will there be any updates on that?
Yeah, I don't think we currently have any plans to research pit cleaning processes. I think those, like I said, they were just suggestions sort of based on my experience cleaning pits and some of what I know about exposure science. But, I'm definitely happy to sort of have a conversation about, what questions you might have specifically about pit cleaning and, how we could help improve those recommendations.
Okay. You described earlier in the presentation the routes of exposure to fire retardants for gymnasts, which would be, or for anyone for that matter, inhalation, breathing it, ingestion, eating it, and skin exposure. And you also described your tests of blood levels in your test subjects, the gymnasts. And I'm wondering if you have any notion of which of those routes of exposure is the most important, or what the relative contribution of each of those.
Yeah, so we think for the general population that incidental ingestion of dust is the most important. I think for gymnasts it's really unclear, you know. Yeah, we'd have to do some research specifically on gymnasts to sort of hash that out. It is difficult to be able to tell the difference between incidental dust ingestion and skin absorption. So I guess I've sort of come down to wondering how useful it is to put a whole lot of time into trying to tease those apart, when clearly just having, just having those chemicals in your indoor environment, you are being exposed. And so that's why I've chosen to focus more on the intervention.
Okay. Another question that we have here is, are the fire marshals in the study agreeable to sprinkler systems as an alternative to needing flame reduction foam?
Yeah, absolutely. That's something that we're definitely thinking about is, if a gym has sprinkler systems, then I think it might be a good argument for not needing the flame retardants in the foam, if we're not finding a real benefit of the flame retardants, but that a sprinkler system might be just more sort of a better way to improve fire safety in the gym.
And from your own experiences, do most gyms have sprinkler systems or not?
I have no idea. So that's in our feedback survey. I'd really like to get some information about that.
Okay,
are gyms going to be receptive to that type of suggestion, or is that going to be problematic?
Okay. Another question that's come in here, to prevent cross-contamination of older with newer pit cubes, is it better to completely replace them with new flame retardant-free cubes? In other words, I
haven't researched that specifically. Yeah.
Go ahead. Yeah, go ahead.
But my thought would be yes, because one thing that we know is that foam is sort of both a source and a sink to flame retardants and other sort of VOCs. So if you put your flame retardant-free pit cubes in a pit with flame retardant pit cubes, you would sort of expect the flame retardants from the flame retardant pit cubes to migrate into the flame retardant-free pit cubes. I'm not sure to how much. You could definitely sort of do a little project to try to find out. But my thought would be, if you can, it would probably make more sense to replace them all. But yeah, we could definitely, if we had funding to do that, we could look into it.
Okay. Another question, how easy is it to get the flame retardant-free cubes? Are the major distributors making this option known, and is it available, in fact, to gyms?
Yeah, so we were able to find a distributor that had flame retardant-free pit cubes, and what we're hoping is that when we finish up the study, some of those distributors will sort of make that they have them more public and maybe even be able to post it on our Gymnast Flame Retardant Collaborative and send it out to you all. I mean, that's the most often, that's the most frequent question we get to the Gymnast Claim to the GFRC is, where can we get flame retardant-free equipment? So that's information we're hoping we're going to be able to provide.
And we have a related comment here, and that is that all foam makers will offer flame retardant-free foam, but be careful of your fire marshal on this change, as that fire marshal may insist on following the letter of the law. And let me just put in a Turd-related comment here. Ironically, as the webinar was going on, we got an email from a researcher out in California who is very big on trying to reduce the use of flame retardants generally. And this is a very active topic, both in the sense of the toxicity of flame retardants as well as the flammability tests that you illustrated in your webinar. So I think we're going to start seeing much more activity on this, and fire marshals may become more and more aware of the real issues with regard to flame retardants. Let's see, another question. Has anyone yet reached out to the gyms around the country to alert them to the problem? Has there been any awareness campaign yet?
Not that I know of. Nothing formal, I don't think. I've reached out to the Federation of International Gymnastics, actually, and myself and William Sands, Dr. William Sands. And so I know that they are aware of this issue, and I also wrote a letter to USA Gymnastics, and I've been told that they are aware of this issue and they're paying attention to it, but they're sort of waiting for some other recommendations to be made and maybe a solution to be found. So I'm hoping to engage them more in this, and and engaging you all, hoping to sort of help facilitate that engagement and find folks who are able to help distribute this information more broadly.
Yeah, okay. Again, a flame retardancy question. Have you found a way to get to the national fire marshals to consider changes to allow foam, a non-flame retardant foam?
No, not yet. Working with a fire engineer, and I think he has contacts in that community, and so I think the thought is that he'll be able to facilitate those conversations.
Okay.
But if anybody on the call or knows of any other leads, please share them.
Okay. Here a comment from Steve Betts. Thank you, Steve. It says BFF Foam, which I guess is the distributor, happily sells non-flame retardant pit cubes, and well, it's BFF Foam. Oh, they are. Hang on here. We just lost that for a minute. BFFFoamCorp.com, and they are also CERT PUR approved, those pit cubes.
That's right. So we've been keeping things really confidential with the distributors we've been talking to, but we are happy for them to out themselves, and if they sort of contact us and let us know that, we can put them on our website. So it sounds like I'll just confirm with Steve by email, but it sounds like BFF Foams would like to be listed on our website, so we can put them up. And I've read their specs, and their foam sounds really, really nice.
And a related comment from Elisa. Elisa says, I know of at least 3 other manufacturers, so you may want to contact her as well. And then a question. Okay. To get covered pit foams, again, it's not a question, it's a comment. To get covered pit foams, call for Rounders Covered Pit Foam, and a phone number is given here. We'll give that to you, Courtney, and you can get that out to people. And that's it. If we have any further questions, please get them in, because it seems as though that's the end of our questions and comments. And again, Courtney, I'll try to emphasize for you the importance of your survey, which will be coming out shortly via email to all of the participants. And do you have any concluding or final remarks that you'd like to leave people with?
No, but just thank you so much for coming. I really appreciate it.
Okay. Well, thank you again from us at Turi as well. It's been a lively chat conversation here, and we appreciate your attending. And thank you very much. That'll conclude the webinar.